So we're going to start off playing with area, and then we'll move on to perimeter. So areas of polygons. Oops, wrong letter. And the simplest is based on the area model that we talked about before, and kids at a young age get a good grasp of that. So area of a rectangle is the first one we'll look at. And the assumption here is that an area, the basic unit for area is a square. So this is based on a basic unit of a square. You can use other things to measure area. Basically anything that will tile can be used to say this is the area. So you could use triangles to measure area, but we typically use a square, like a square inch or a square foot or a square centimeter, and so on. So if I have a rectangle, I would want a base and a height that are perpendicular to each other. And so let's label these. And some people call them length and width, and that's fine too. You can call them that, and that's more common. The reason I call them base and height is I struggle with determining which one should be the width and which one should be the height. The base and the height have to be perpendicular. If they're not, it's not a rectangle, right? So that's important. And when we use the words base and height, we're talking about two perpendicular, there we go. We're talking about two perpendicular lines to each other. And so we will talk about that with other figures besides a rectangle. And then the area is just defined based on the idea of using a square as the measuring unit, is that base times the perpendicular height. Okay, and again, I can't emphasize this enough, because we use square units to measure area, the base and the height must be perpendicular. And if you don't remember perpendicular, it means meets at a right angle. So meet at a right, whoa. At a right angle. All right, so that's our basic unit. The idea of a square is what we measure with, and then how many squares are in something. And sometimes it's a whole number of squares, and sometimes it's not. So we're going to extend the basic area of a rectangle to other shapes, and we're going to start with a triangle. So hopefully you all can see. Am I on the right account? Which account do I want to be? Yeah, I can be on this one. From the home page or from the assignment page, however you choose to get there. There is the area and perimeter activity that we're going to do now. Now, you can do this on plain paper like I have on my digital whiteboard. Graph paper would be useful. Dot paper is helpful also, or a Geo Board app, and I link to one here. So if you're on a computer right now and you can multitask the Zoom meeting and other activities, then, excuse me, I highly recommend checking out this Geo Board app. So I'm going to open that up. And there's a few versions of this Geo Board here. There's the basic view here, which is a 4x4 grid. And don't get confused. There are 1, 2, 3, 4, 5 pegs, and those pegs are needed in order to make 1, 2, 3, 4, let's call them inches. Okay, so this board is 4x4 units. The area of this board is 16 because there are 16 squares based on those side unit lengths. There's also a bigger board you can get that has more pegs in it. And again, usually we assume that the distance horizontally or vertically between these pegs to be 1 unit, and then we go from there. So if you need more room to work, you get that one. And then there's the crazy circular one, which I'm probably not going to use today. I'm just going to stick with the basic one for now. So in this basic one here, some ideas that I'm going to play with are if somebody makes a triangle, so I'm just going to make some triangle. Let's suppose that's my triangle right there. And I want to know what is its area. There's two ways to proceed to find the area here, aside from using a formula. So I'm going to avoid using a formula for a minute. I'm just going to use the basic idea of a rectangle at first. I could try and cut this thing up. Oops, let's make it red again. By say, I should have used yellow. There we go. So I could cut this red triangle by drawing an internal line inside of it, and that is called a decomposition of the triangle. And then if I can find the areas of these smaller triangles easier, then I get the area of the big triangle. So we're going to play around with the idea of finding areas based on rectangles, but with other shapes. And we're going to use either decomposition, which is what this is, or you can make a composition. And a composition means you're basically making a bigger shape. And so I'm just going to draw this shape around. Okay, so I draw the smallest possible rectangle around the figure I'm considering. So here's my original red triangle, right? I drew a rectangle around it. That's the smallest possible rectangle I can draw by making sure the vertices of the triangles are either on the edge or completely within the rectangle. Now this rectangle happens to be a square, and that's okay. So what's the point of this composition decomposition thing? The point of the composition decomposition, and let me bring up another screen for that with the Geo Board. Let's make that 2 by 2. Oh, by the way, to move, this is supposed to, a Geo Board, if you're not familiar with one, is usually a wooden or plastic pad with pegs sticking up. So I have a bunch of wooden ones with nails sticking up at a regular interval like this, and I have some plastic ones too. You may have seen them. And to move a point, you grab the end of the elastic. To land a new point that doesn't exist, you grab somewhere in the middle. Okay, and so you kind of get used to when do you grab a point to move it and when do you grab an edge to move to a new point. So you can make all kinds of shapes. So let me go away. There we go. All right, so here's a 2 by 2 square. So it has a base of 2 and a height of 2, so it has an area of 2. I can then split, oops, stop it. Okay, click versus drag is important here. All right, I'm gonna cut this rectangle in half. And so I just wanna play with this on my screen for a sec. So screenshot, Geo Board. Page. Okay. Oops, I don't know what I wanted there. And let's mark this sucker up in maybe yellow. So this rectangle has a base of 2 and a height, H-E-I-G-H-T, of 2. So that means its area, which equals base times height, is 2 times 2, or 4. And since I don't know what the distance is between here and here, there's just 4 squares inside here, so I would just call it 4 square units, which can either be written out as square units, or sometimes we might write 4 units, and then we might square the unit. So the unit is being squared, not the 4. So there's a couple ways to write that. Now I just cut this in half with this diagonal, and when I did that, I just made a triangle. So choose red, maybe for the shading. Will that show up here? Sure. Ooh, I got my pad turned the wrong way. Try that again. Oh, it's not much better. Sometimes I can trace good, sometimes I can't. Anyway, okay, so there's a triangle right there. And would you agree, like I cut this thing in half with the diagonal, so that triangle right there is half of. So, a right triangle.
Hey.
Hello, dear.
Yes.
A right triangle is definitely easily half of a rectangle. So for sure, I know that for a right triangle, if I take its base, so in this case, I would say up here is the base of the triangle. I like my bases to be horizontal. And I multiply by the heights, H-E-I-G-H-T, and this is super important. The base and the height have to meet at right angles. So if this is the base of my triangle up here, this would have to be its height. I couldn't choose this red line to be that height because that red line is not perpendicular to anything. And perpendicular means meet at a right angle. So now if I take the base times the height, that gives me the whole rectangle. I only want half of that. And so I can get half by either dividing by 2 or multiplying by a half. You choose. You get the same answer either way. So this triangle right here, I could say has an area, so triangle area of, let's see, what would that be? 2 times 2 divided by 2, which is 2. That's a lot of 2s. That's cool. So this has an area of 2. And you can kind of see it in here. So if I get out, let's see the red color here, and I say I draw this line here, and I cut across over there. Here's 1 square unit. This is half of a square, and here's another half of a square. So I can kind of do a decomposition. 1 plus a half is that 2 over there. So there's a bunch of ways using composition and decomposition to play with triangles and areas. So we're going to use a couple of facts. That a rectangle area is base times height. That a right triangle has an area of base times height over 2. And some people like to call it 1/2 times the base times the height. And so either way is okay. Multiplying by 1/2 is the same as dividing by 2. So whatever your version of it is, and it depends on the day. Sometimes I like this one, sometimes I like that one. So those are the tools we have. We have right triangles, we have rectangles, we have composition and decomposition. So let's get busy. New page. Show desktop. Activity. Okay, so on this activity, I give an example here, and I state some of the rules, right? The area of a rectangle is base times height, so we get that right here. And then since a right triangle is always half of some rectangle, its area is always base times height divided by 2. So those are some of the given things. And then we're going to use the idea of composition and decomposition. So then here I say the yellow triangle above lives in this 3x4 rectangle. And I probably should have called it a 4x3 rectangle because I usually state the base first. Oops. This rectangle makes a composition around the triangle since it's outside of the triangle. As opposed to, do I have any decomposition pictures here? Yeah, over here on this trapezoid. So this is a decomposed trapezoid because I'm cutting it up internally. This is a composition of a rectangle around the trapezoid since I'm drawing outside of it. So composition versus decomposition is the way I'm using these terms. Okay, so let's play with this one right here. So either drawing this on a piece of paper or looking at it on the screen or bringing it into the Geo Board. I'm just going to grab a screenshot of it. Oops, wrong pad. Let's blow this up a little bit. Screenshot it. It's funny because this is a screenshot of a screenshot now. Just a little weird. Add to current page, I think. There we go. So I'm just going to scribble on this a little bit. All right, so what do we got here? Let's use green, should show up okay. We have a 4x3 rectangle. So we're starting off with a rectangular area of 3 times 4, which equals 12. And what we want to do is we want to whittle away these outside triangles to get to our golden triangle inside. So I need to find this triangle area up here. And when I look at this one up here, it has, let's call that the base there, 1, 2, 3, 4 units. And like the rectangle, it has a height of 3 units. So from the rectangle, I need to take away that triangle. So let's see, what is that? Base 4 times 3, divide by 2. So that's 12 over 2, which is 6. So I'm going to have to take away from that 12 a 6, and that's going to leave me for the remaining area, another 6. And then I want this area here to go away, so I'm only left with the triangle I want. And this one here, let's use a different color. Let's say red. It has a base of 2 and a height of 3. And so its area would be 2 times 3 over 2. Now, remember, we can also write that as 1/2 times 2 times 3. And those are going to give me the same thing. Yes, I can certainly slow down. Sorry. Let me know if there's something you would like me to repeat. Got it. So I'm just going to make a note here. Let's see at the bottom. From the big rectangle. So this is kind of the composition decomposition routine. We want to remove the extra triangles. And that'll allow us to discover the area of the triangle I want right here.
Hey, Mr. Parker, why is it not 4 by 3?
This one I'm working on right here?
Uh-huh.
Yeah, so I'll just outline the triangle I'm working on. So I have this big rectangle outside, right? I would like to get away the upper left and the lower right triangles. And so the lower right triangle I'm referring to is this one right here. I need this to go away. And the distance across the bottom here is 1, 2 units for just this triangle. It has a height of 3. See what I'm saying now?
Yeah, okay, I get it now.
Yeah, so I'm just trying to get rid of this. So I'm like kind of trying to erase it here. So I essentially, because of this -6 over here, I erased this triangle right here. So this is now gone. I just subtracted it. It's gone. Now I'm trying to get rid of this one right here. And so it has an area of 1/2 of 2 by 3. So either way I calculate that, I get 3 for this triangle right here. So this one has an area of 3. This one had an area of 6. So from the 12, right, I already took away that 6. Now I have to take away this 3. So -3 leaves 3. So from my composition and then decomposition here, I think the yellow triangle has an area of 3. So let's write that down. So this shows the yellow triangle has an area of 3. And we're going to do this a few more times to try and get used to it. Okay. So again, this thing right here, I think, is 3 square units with the other stuff gone. And so we will try this again in just a sec. How you doing, Yazal? Getting a little caught up on that? Okay. So let's go back to the activity. So I in this paragraph, I describe what I kind of showed in that other. From this 3 by 4, this 4 by 3 rectangle, I need to cut this upper left triangle away And it's a right triangle, which means it's easy to work with because I can clearly see the base and the height. And then over here, I can take this right triangle out because I can clearly see the base of 2 and the height of 3. After I cut those away from the rectangle, all that's left is this yellow figure, and so it has 3 left. Okay, so we're going to repeat that idea for each of these triangles right here. And I think I zoomed out too far. Oops. So we want to just identify what's the area of each of these, and I'm hoping for a brief explanation or a little sketch that shows it. So some dot paper or graph paper, but you can pull this off on plain paper. So I'm gonna, let's see, I'm gonna do some of these, but not all of them. I think I'll do the first, second, and third one, and then you can do the others. And then there's another fun activity related to this down there. So new page. And page. There we go. All right, so I'm going to try to draw this freehand by looking at that picture. Let's switch to black. So I'm going to just draw myself some dots to the best of my ability. Try and make them in a square grid. Okay, and let's copy those so I don't have to redraw them. It's not too bad. Got it. So the first triangle I showed was a right triangle with the right angle down on the bottom left there. So it looked like that. And so looking at this, I can see it's got a right angle here. So I'm going to choose to call this the base, and that is a base of 2. And this then would be the height. And the important thing about the base and the height is that they meet at a right angle. And so the height appears to be 3. And so based on that, I can just say the area is 1/2 times that base times that height. So half of 2 is 1. 1 times 3 is 3. So this triangle has an area of 3 square units. Okay, so that one's pretty straightforward, just based on what I said earlier, that a right triangle is always half of the base times the height. So then for the other one, Control V, I think I can put it on this screen. Oops, oh, no. Ah, I lost it. Okay, Control Z, Z. Oh, really? I put them all in there one at a time? That was weird. All right, let's try that again. Control V, and hopefully this time I can move it. Yeah. All right, so I'm going to do figure number 2. So figure number 2, I'm going to redraw. That was an isosceles triangle. We talked about isosceles triangles way back in the beginning, near the beginning of the quarter. Now this isosceles triangle is not a right triangle, so I have to either decompose it or make a composition around it. Does somebody want to make a suggestion? Cut it up inside or draw around it to get its area?
Down the middle.
All right, that's an excellent suggestion. So we're going to use decomposition here. So I'm just going to make a note. Oops, that's not a pen. Again, decomposition. Because if we make a line right down the middle, we have 2 right triangles. So there's my line down the middle to the best of my ability, and there's a right triangle, and there's a right triangle. And so this right triangle has a base of 1, and this right triangle has a base of 1. And here's my right angle, so this must be the height. So both of them have the same height, which is 3. So let's call this triangle A over here and triangle capital B there. The area for A would be 1/2 times 1 times 3. And the area of triangle B is also 1/2 times 1 times 3, right? 1/2 base times height. So 1 times a half is a half. Half of 3 is 1.5 or 1.5. So this side has an area of 1.5. This side has an area of 1.5. So then the total area here is 3 square units. Yeah, so we can break it up on the inside into right triangles sometimes, and we can try it on the outside. And the key is you got to be able to do two things. When you break it up, you have to be able to identify a right angle. And based on that right angle, you need to be identify bases and heights. And then you can move forward. All right, so we're making progress. I think it's pretty straightforward. We can look at the third triangle and say, hey, that's just the mirror image of this triangle here. It's 2 by 3, so it has an area of 3. Let's do this one over here next. So I'm going to try to draw that to the best of my ability. Back here, so I'm doing the fourth triangle there, and I need a new page. Paste those dots in and draw a few more dots. Oops. And use black, so I think I need another column of dots to make that happen. And if I did this right, it has a base. Oops, wrong color. Choose red. We're going to go 2 across. And then this one goes up there, and this one connects back down there. And it's not wanting to go in the right spot. Close enough. Looking back, did I do an okay job of drawing that? Yeah, so this line hits each of those points. So it has a slope of up 1 over 1, up 1 over 1, up 1 over 1. And my figure roughly shows that too. So I'll just make those dots a little bigger. So we're hitting that dot on the line, that dot's on the line, and so on. Okay, so this is our figure right here. So we have to decide whether we want to break it up inside or outside. Now I'm going to go for outside here. Inside is a problem. If I tried to say, you know, like draw this line right there, I'm not positive that's a right angle right there, and I don't know that length. Okay, so this is super important, and we'll test this idea out in a minute. What I know in this figure is that the distance horizontally is 1, and the distance vertically is 1. That diagonal is not 1. Okay, so that's important. So I'm going to do an external drawing on this. So let's see, draw it in green. So I'm going to, the smallest rectangle I believe I can draw is a 3 by 3 rectangle around this. And that'll contain the whole thing. Okay, so I have this, oops, outer shape. That is 3 by 3, so it has 9 square units. And then from that big thing, I need to find the area of this right triangle here and remove it, and then I need to find the area of that right triangle there and remove it. So what are the dimensions of my upper triangle here? Let's say it is what, 1, 2, 3 units across, and it is 1, 2, 3 units high. So I need to take away, pen is behaving strangely, that upper right triangle, or no, that's left, isn't it? Yeah, sorry, upper left triangle. And it is 3 by 3, but it's a triangle, a right triangle, right? There's my right angle. So I have to cut that in half. Oops. So 3 times 3 is 9, and half of 9 is 4.5. So from that 9, I have to take away 4.5. What does that leave me? Anybody? Caitlin? Kayla? Like to chime in?
4.5.
4.5, correct. Thank you, Jimmy. So that leaves 4.5. So I'm just going to make a note here. Let's use a highlighter, red. This thing here is now gone. Bye-bye. All right, so next I need to strip this one off down here. So I need to identify its dimensions. So it is definitely a right triangle, and the base of it is 1, and the height of it is 3. So next I'm going to take away the lower right is 1/2 of 1 times 3. So that's half of 3, which is 1.5. So now I need to take away 1.5 here. And that leaves me 0, 3. You guys had, excuse me one sec, you guys. Are you guys heading out? Okay, I'm back. All right, so it looks like this, let me make a note. Let's see, this is gone. Oh, hang on one sec.
I don't want to go.
Okay, I'm back. So again, what we found is through the composition, decomposition, that the area inside here is 3 square units. Switch shoes, Julia. Okay, so area of this guy is 3 square units. All right, so what have we discovered here? Let's look back. I'm going to grab all 5 of these triangles here. So screenshot, triangles, new page. We've discovered for the areas, this one has an area of 3. 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 And this is actually the example I gave above, if you hadn't noticed that. This one has an area of 3 too, also. Okay, what else do these have in common besides the area? Anybody? Let's brainstorm here. They all have an area of 3. We got that. They have a bunch of other things in common. There's 2 very important things I'm hoping we can identify. Is anybody there? So either reply with, I don't see anything, or reply with something else each of these triangles has in common. Okay, we got an I'm not sure. There's nothing wrong with guessing and being wrong. Like, first thing I thought is, well, they're all triangles, duh. Okay, but we knew that. Since all the triangles, same internal angle measurements. Oh, yeah, the sum of the angles inside is 180. This is true. So let's see. Other things they have in common. Let's just make some notes, trying to get to the ones I'm hoping to see. They're all triangles. They're not all right triangles, and they're not all isosceles triangles, but they are triangles, right? This is a right, this is a right, that's isosceles. Let's see, we know the sum of the angles inside is all 180. Sum of Interior angles for all of them is 180 because they're triangles. And it turns out that doesn't help, but it is something they have in common. What else? So we know the sum of their angle measures is common. Do they have any other measures that might be in common? What do you notice about the bottom of each of these triangles? They are the same distance, yes. And what is that distance? They all have a base of 2. Every single one of them, right? Look across the bottom, base of 2, base of 2, base of 2, base of 2. Now, once we identify that base, we can kind of say there's a ground level right there, which is the same ground level here. And these guys all have the same ground level. How high is the tip of each of these triangles off the ground? Anybody? Three. That is correct. Yeah. When we're measuring how high something is, we always go from the tip straight down to the ground. So the distance from that point to the ground gives me this dotted line. That dotted line is often referred to as an altitude. If I go from this tip here down, straight down to the ground, so I hit at a right angle, again, that's another altitude, which is also another word for height, okay? So the altitude of every one of these triangles is 3. And the base of every one of these triangles is 2. And the area of every one of these triangles is 3. So it turns out that area formula for right triangles, it doesn't matter if the triangle's right, as long as you can identify a base and a height perpendicular to it. Okay, so I'm just going to isolate one of these triangles to verify this. Let's grab this one here. Add to new page, please. And blow that sucker up a bit. Oops. So first thing I decide is which side's going to be the base. And because this one's already horizontal, I'm going to choose this to be the base. So here is my base, and my base is 2. Next thing I have to realize is that base makes a whole base line. And then if I can get a height perpendicular to that, it doesn't matter whether that height is inside or outside the triangle or on the edge. That is a right angle. So I can say this must be the height, because it is perpendicular. And see, this perpendicular is important. So this has a height of 3. We already knew, based on a different technique, the composition decomposition, that the area within this sucker is equal to 3 square units. And it turns out all of these measurements match the formula that the area equals 1/2 times the base times the height. So plugging those numbers in to check, we believe the area is 3. Does that equal 1/2 times 2 times 3? 1/2 of 2 is 1. 1 times 3 is 3, so it does check. So it turns out this is the general formula for the area of a triangle. Oops. Not going to slice it through there like that. So this is general area for any triangle. Now the catch is you have to be able to identify a base and a height that are perpendicular to each other. If you can't do that, you can't use this formula. Okay, so I'm just going to give an example that makes this a little bit harder. Show desktop, Geo Board, and let's delete this stuff. Delete. Okay, yeah, let's use a different version of, no, let's not use that one. Delete. Oh wait, I know what I want to do. Let's see, I'm just going to move you over there. Okay, so here I have a triangle here. And usually when I'm trying to identify a base and a height, I want to have one of them be horizontal so the other can be vertical. But I have no horizontal or vertical lines here. So let's take a screenshot and see what we can do. So suppose this was my triangle. And do I want to make it bigger? Nah, it's big enough. And add to new page, please. Perfect. So I can do this with the decomposition method by saying, all right, well, oops, wrong tool. Let's draw a rectangle around this by saying the smallest possible rectangle is probably this one right here. And then from that, oops, I need to figure out how to get rid of these extra triangles on the edge. So I'm starting off here with a square rectangle that is 2 by 2, so it has an area of 4. And I want to whittle off these corners so I get the red triangle back. So this first one right here, this triangle right here is 1 by 1. So its area would be 1/2 of 1 times 1. Half of 1 is 1/2. So that first one has an area of 1/2 I need to get rid of. So let's just make a note of that inside here. That this thing has an area of 1/2 square units. Moving over to this one is 1 by 2. So its area is 1/2 of 1 times 2. So half of 1 is a half, half of 2 is 1. So it has an area of 1. So this is 1 square unit. And then lastly, this one down here, I could say it has a base of 2 and perpendicular height of 1. And so pretty similar to what I just did, 1/2 of 2 times 1. Half of 2 is 1 times 1 is 1. It also has an area of 1 square unit. So from the 4, I need to take away that 1/2, and that's going to leave me 3.5. So that gets rid of this one right here. Then I'm going to take away that one right there. That leaves me 2.5. So now this is gone. And then I'm going to get rid of that one by subtracting 1 again. And that leaves me 1 and 1/2. So the red figure, the red triangle inside, it looks like its area is 1.5 square units. And so that's from decomposition. Because there wasn't an obvious perpendicular base and height. Now, some people would look at this and they might see something hiding in there that could be useful, and it might be, I'm just going to copy this into my next screen. Oops, my Zoom tools are in the way. New page. So someone might look at this and say, well, what if I said, is that my highlighter? Yeah, what if I said this was the base right there? If that's the base right there, couldn't I go straight from the tip over to there and make a right angle? Doesn't that look right? So a couple problems with this approach is I would have to show somehow that that really is a right angle if I want this to be the base. Okay, so there's several problems with this approach. Is it doable? Yes, but it's hard. And I'm not going to do it here today. I might do that next class. I would have to find this length right here. And that length right there, I'm just going to kind of redraw it over here. That length, that base, is part of this right triangle. And does anybody remember how we relate the sides of a right triangle, what we could use there? Oops, I lost Giselle. How long ago? Sorry, Giselle. 1 minute ago. Okay, so I'm going to go back to the previous problem. Oops, who did I lose? Caitlin. So this composition, decomposition here, that's okay. If one person has a question, everyone else probably does too. Or was it after this year? And these take some practice, so you definitely want to, on your own, draw some of these. In the next part of this activity, you're going to have to draw some. It's with the decomposition of the square. Okay, so I'll do another one of those in just a second, and then I'll post these notes too. So just let me go back to this for a second. Next page, and I'll do another one of those for the next part. If this, to find that diagonal, I got to use the Pythagorean theorem, where this would be A, that's B, and that's C, and I have to use the A squared plus B squared equals C squared to figure out what the length of C is. So trying to say that's the base and that's the height means the Pythagorean theorem has to get involved, and this is just way harder. And I'll come back and do this one next class. It's beyond what I wanted to do today. So let's do one more problem like this, and then I'm going to set you free to play with this. We'll talk about it next class. The next part of this assignment, so we pretty much did this first part here. We identified the areas of each of these triangles. That was the goal. And show some work. So we have some sketches to go with it. The next thing I wanted you to do is on a Geo Board or dot paper or graph paper, make 3 different triangles that each have an area of 3.5. Now these triangles each have an area of 3. So I want 3 triangles that are just a tiny bit bigger than these guys here. So I'm going to try and make one right now. So to do that, I need a Geo Board. And let's clear this one off. And my zoom tools are in the way there. They're in the way everywhere. Okay, so I'm just going to copy this here to my screen. And just play around. It's fun to have the version of this that's real with elastics, because then you don't have to do erasing and stuff. Okay, so I want to make something, a triangle with an area, and this is going to take some experimentation of 3.5, 3.5, however you want to call it, square units. And so it's got to be a little bit bigger than the last one. So for example, in the last one, I had a one that had 2 across the bottom here. And then let's say we go to that piece right there. So this triangle right here was in the last example. That has an area of 3. I need it to be a little bigger, which basically means it needs to be wider or taller, okay? So I could say, oh, okay, well, let's maybe just kind of experiment. What if I made this line go out wider and then just made it just as tall? What if I did that right there? Oops, I missed. What's this triangle? Well, let's see. It's a little bigger. What's the base on this thing? Well, the base appears, oops, it's not a pen. The base seems to be 3 units. What's the height here? Well, height looks like it's 3 units too. So the area, it is a right triangle, right? Those do meet at a right angle there. So the area of this thing here should be 1/2 times 3 times 3. Okay, well, 3 times 3 is 9. What's half of 9? Oh, that's 4.5. Darn, see, that's too big. Okay, so we got to get creative when we're playing around here. So that didn't work. Too bad I didn't ask for a triangle. That was 4.5 square units. C, copy, new page. All right, try again. So you're going to have to experiment a bit, and it's going to involve a bunch of composition and decomposition. So other things I could try are, instead of making it wider, I could start with that 2 and then just make it taller. Would that work? So what is this one right here? Well, it has a base of 2 and a height of 4. So 2, so that would be half. I should write it up top before. The area is half of 2 times 4. 2 times 4 is 8. Half of 8 is 4. Ooh, it's still a bit too big. Okay, so this is a tricky problem. And it may be that this grid is kind of too small to work with. We might need to play with a different grid. So let's see, we have that other grid we could play with that's bigger, or we could keep playing with this one. So this gives me more dots to play with, so I can kind of mess around. You might need that. I think I can do it here. So I'm going to try one more time. And I hope you guys realize I'm messing around on purpose. I don't want this to be too easy, but I don't want it to be too hard either. And all new problems are hard at first. And then once you do it, it's like, oh, right, duh. Okay, so I think I'm gonna have to go off at an angle, maybe. So I tried to make a base of 2 with some different heights, a base of 3 with a different height, and those were a bit of a struggle. I'm trying to find an area, again, that is 3.5. Okay, so there are lots of ways to go about doing this. And I could just play, or I could use a formula. So I'm going to play one more time. What if I draw that line and then maybe come up there and then go over there? Let's see, is that going to be too big? I think this is not going to work, but let's test it out. So to test it out, I'm going to have to do a decomposition around it. So draw the smallest rectangle you can, because this has no right angles in it, and I can't chop it up easily inside. And then what I want to do next is I want to remove this upper triangle here, and this lower right one, and that lower right one. So to do that, I have to identify their sizes. So this one is 4 across and 1 tall. So its area is 1/2 times 4 times 1. Half of 4 is 2, times 1 is still 2. So this one has an area of 2 square units. So from the big rectangle, we'll take that away eventually. This one over here is 2 by 2. So its area is 1/2 of 2 by 2. Half of 2 is 1. 1 times 2 is 2 square units. So I'll have to take that away in a minute. And then what's this one over here? This one is 2 by 1. So its area is 1/2 of 2 by 1. Half of 2 is 1, times 1 is 1. All right, so what's the whole thing? The whole rectangle is 2 by 4. So, oops, wrong color, let's try green. 2 times 4 means the whole rectangle had an area of 8. And then I need to take away this 2. That gives me 6, so this is now gone. Then I'm going to take away this 2. That's going to give me an area of 4. And then this down here had an area of 1. So I have to take away that 1. That gives me an area of 3. Darn, not 3.5. Okay, so this is a tricky problem I gave you. You're going to have to play around a little bit. So I'm going to stop here. This has been going on a bit. So that was another example of composition, decomposition. to try and find an area when we can't easily find a base and a height. And sometimes you can and sometimes you can't. There's no easy base and height for this triangle. That is not a right angle right there. And we could prove that if we wanted to, but we're not going to today. All right, so your goal right now, or the next day or so, is to, if you haven't already, read section 11.2 in the book and tell me what the main points are eventually this week. And then work some more on this. We did the part A here, and I was playing around with part B, but we didn't yet find a solution for the 3x5. And I'm hoping you can come up with 3 different ones. And they got to be different. Like here I have 1, 2, 3, 4, 5 different triangles that have an area of 3. And I just accidentally made a new triangle with an area of 3 right there. So this is going to involve some experimentation. Another way I could experiment on this before I shut up is area of a triangle, remember, is 1/2 times the base, times the height. And we want that result to come out to 3.5. Now remember, 3.5 is really 3.5. Or as a mixed number, 3 times 2 is 6, plus 1 is, this is 7/2. Okay. Now think about this right here. I could also view that as base times height over 2. So one way to look at this is I need a triangle that somehow has a base times a height that equals 7. The problem with that is the only way I can get with whole numbers, which is what I'm playing with here, base times height equals 7 is 1 times 7. Because if I had a triangle with a base of 1 and a height of 7, and I cut that in half, what's left is 3.5. And I can't get a height of 7 on this screen, which is one reason I recommended maybe on that Geo Board app, you could switch to this one where you have more dots to play with. But it is doable to find at least one 3.5 square unit triangle on this screen right here. But I just gave you a way to find one on this screen right here. So play around, see what you can do. If you can try and finish this, great. Otherwise, I'm going to go over some of the rest of this next class, where we're going to play with parallelogram areas and trapezoid areas, and then their formulas. And then we'll do a little with the Pythagorean theorem, which we looked at a while ago. We're going to review that here. All right, that's it for now. I'll be back on Wednesday. Hope you all have a good day. Stay out of trouble and do good math. Bye-bye.